Yeah, it started recording. You can go on.
Okay, great. So the first thing is let's discuss what we are going to cover in this workshop. So in the beginning, we'll introduce to you what CLI is and what you can use it for. Then we'll show you some basic commands that you can run on the command line. We'll moving on. We'll show you some remote logins. These are some advanced commands that you can perform. Then we have the Linux file system structure, package managers, concepts of piping and IO redirection. We'll explain to you what they are. And finally, we'll have different CLI editors. Okay, so first thing is you may be thinking that what is CLI? So basically, CLI is the command line interface. So like what does command line interface mean? Uh, Command line interface is actually like all in other interfaces. For example, if you have a web interface, so an interface basically provides you a medium of connecting two different things. For example, a web interface provides the user to connect with the functionality that the website offers. So in a similar manner, the command line interface is basically an interface that provides the user a connection to the operating system. Okay, so what uh, it's basically like you type text commands and then you can execute those commands on the computer. So a little bit history about CLI. In the beginning, like when computers were quite new, the GUI, that is the graphical user interface, that was invented after computers started having mouse. So when after mouse was invented, it is after that the GUIs were invented. So before there were GUI and before there were mice, so at that time, if you had to operate a computer, you would have to type the commands. So other than the keyboard, there was no other way of performing actions or running programs or commands on the computer. So that was the time when only CLI existed. But after that, after the invention of mouse and GUI, a new era of pointing and clicking kind of operation came into existence. And that quickly caught on because obviously a GUI is very attractive and easy to understand compared to the CLI. But that is how the world moved from using only CLI to using GUI. But even today, CLI has a lot of uses, especially for developers and system administrators. The CLI is an extremely useful tool to have and learn. So I hope you are clear with what CLI is. This entire presentation that you are seeing, that itself is running on the CLI. So you can see that you can do tons of things and really advanced things on the CLI. So what can you use CLI for? Okay. So what can we use CLI for? So the first thing is working with files and directories. Okay. So no matter what the operating system you have, for example, let it be Ubuntu, Mac or Windows, all these three operating systems have a GUI file manager. All right. So choosing what you do is you double click on the icon for the Explorer or file manager, and in that you can then see the folders that you have, the files that you have. You can create new folders, create new files, read from files, write to files, rename the files or delete the files. So all these things you can do with the help of GUI. Even you can find the files using the file manager. All these things can be done using the CLI. So you can create new folders on the command line. You can create new files on the command line, rename, run, and search for files through the command line. For example, let me show you. So right now, as you can see, I am in this particular folder. And if I wanted to see what content I have in this folder, so I can use the ls command. I hope this command is familiar to everyone. If not, then this command is what this command lists the contents of a folder. Okay, so as you can see, we have some files here. So this command is used to do that. And other commands such as cd will help you to go to a different folder. Then the rm command and rmdir command, these commands help in deleting files. And commands like cp will help you to copy and paste files from one folder to another. So in this way, you can use the CLI to work with your files and directories. The next thing is opening and closing a program. So if you want to open Chrome, so the general steps are that you double click on the Chrome icon and it opens. So Chrome is basically a program, right? If you want to open VS Code or any other application, you double click it and it opens. What you can do the same things from the command line as well. So you can open applications, you can open different programs and run them. You can open files using the command line. So let me show you an example of that. Let's say I want to open, okay. Let's say I want to open this welcome.md file in VS Code. Okay. So the command for that is code. That is, this command tells that, okay, we need to open whatever comes after that in VS Code. So code and the name of the file. Command has been executed and we see that VS Code, we have opened the file in VS Code. So in this way, you can use command line to open files and open programs and applications. Then the next part is manage computer processes. So basically, you may be aware of the task manager. Of course, everyone is aware of task manager. So once again, you press Control Alt Delete and a window shows up with the list of programs that are running, and then you can click on them, select them, and basically terminate them. You can do the same thing with the CLI as well. So you can use a command called top, which will list down all the processes that are running on your computer at that point of time. And then there are different commands. One of them is kill, which can be used to stop a process. So you can manage your computer processes through the CLI as well. The fourth point is perform. The fourth point is that we can perform repetitive tasks. So for example, let's say you have a folder, okay, and in that folder you have around 100 images, and you want to rename each one of them such that the first image has one in its name, second one has two, and so on. So in file, using a file manager, I mean, I'm not sure about Ubuntu and Windows about this, but in Mac we can do this using the GUI, but it will be more in a better way. We can do this on the command line as well. So for example, in that case, there are commands, you can chain 2 to 3 different commands together to achieve that. The exact commands I'll tell you later. So I hope you are clear with what you can, like, why can you use, what applications can you use CLI for. If you have any doubts, please let me know.
What is the difference between command prompt and CLI?
Okay, yeah, we'll get to that. Command prompt is basically, there are two meanings for command prompt. One is the command prompt application that is present in the Windows, and the other command prompt, we'll get to that in a moment. Okay, so before we move on, let's discuss some differences between CLI and GUI. The first point of difference is less resources are required. So when you run a GUI application, a lot of system resources are being used to output the windows and the content onto the screen. But using the CLI requires very less resources. As everything that you do is basically a text command. So there is only text present and there is no graphical content on the screen. So it requires very less resources compared to GUIs. The second difference is high precision over commands. So basically what that means is, for example, let's say you are a developer, okay, and you have built certain application and it has some functionality that, suppose you don't want users to use that functionality. Okay, in that case, what you can do is you can not provide any way to access that functionality in the GUI. So for example, if you didn't want user to go back to a previous screen, then you simply don't put the back button, right? So in this way, like you can, the developer can hide or show different things based on the GUI. But when it comes to commands, okay, the things that you can do using the CLI are far more precise and allow you to have more control over the operation that you want to perform. That's why like GUI can restrict you in some ways, but commands can provide you full control over it. Once again, easy to automate repetitive tasks. So like I said, you can, I gave the example for renaming large number of files. So in that way, there are several tasks that you can automate over the CLI. But if you wanted to automate a GUI, like it's not possible to write something that takes your mouse cursor over a particular button and presses it. That kind of automation is not possible. So in this manner, CLI is still better than GUI. And finally, it offers more power and control. So like I said, there are no restrictions on using the CLI, as long as you know what you're doing and the commands that can be used to do that particular task. You won't face any kind of restriction. And the only kind of restriction that you face while using the CLI and performing some particular tasks are whether or not you have the required permissions to execute those tasks or not. So permissions are once again like important. So those are the only kind of restriction that you can have when using the CLI. Is there any doubt till here? Okay, then we can move on to the next part. Okay, so command line parameters. Okay, so basically, okay, if you're on the, okay, so now you are on the command line interface. Okay, this is the command line interface. The terminal that you see is the command line interface, and you type your commands where this particular thing is there. In your case, it may look differently. So that is where you type the commands, and these commands are then processed by the shell that is behind the command line interface, that reads and interprets your commands, and then instructs the operating system to perform the relevant operation. So what do you mean by command line parameters? Okay, so any command that you type on the command line interface basically has the following syntax. It is first we write the command itself, okay, and then we provide some optional arguments and some optional options or flags. So a command line argument is basically an item of information provided to a program when it is started. So what does that mean? Okay, so if you are like in any programming language, if you are writing a function, okay, so if you're writing a function and you want that function to work on different types of input, so what do you do in that case? Basically you pass in arguments to that function, right? In the same way, you have a particular command, but we want that command to be executed over different types of files, right? So what you do is you pass a command line argument. Okay, let me show you an example. For example, ls is the command over here. So ls by itself will work perfectly fine and it will display the contents of the current directory. But let's say that without going into this sort demo directory, I still want to print the contents of that directory. So in that case, what I can do is I can say ls, which is the command, and pass an optional argument here. And in this case, the argument is the name of the folder. Okay, so command and the argument name. When I do this, I get the contents of this particular folder. So here we see that we have run a command with an argument. Now it's not compulsory that you have only one argument for a command. Just like in a function, you can have multiple arguments. Even here, you can have different arguments for the same command. And that really depends on the type of command you're going to use. The next thing that you write along with a command optionally is a flag or a switch. That it is something that modifies the operation of a command. So, okay, once again, consider that you are a developer and this time you are developing a command line program. That is basically you're developing your own command. Okay. So let's take the example of the ls command. So if you were developing ls command, in that case, what it does primarily is that it lists the contents of the directory. But now you want that the command should also list the hidden files in the directory. So what do you do now? Do you design an entirely different command to do that? Or is there a way in which you can modify the existing command? So this is where flags and options come in. So a flag or option basically indicates to the shell that the command needs to be used, but it needs to have some kind of a modified operation. Okay, let's try that. So for example, I don't know if there are any hidden files here, but let's try this out. So ls minus a. So minus a is the flag here. Okay, sort demo was the argument and ls minus a here, minus a is the option. So options basically have a dash before them, one dash or double dash, depending on the command and the option. Okay, so let's try this out. Okay, so we saw that there are some hidden files over here, such as .dstore, dot and dot basically represent a way to get back to the previous directory or indicate the current directory. But there is one hidden file over here. So basically you can have a command, then an optional argument, and then an optional flag. All right, is this part clear? The syntax for the command. Are there any doubts in this part? If you have any doubts, please write it in the chat section, and someone please unmute and ask them, because I can't see the screen right now. Okay, so if there are no doubts, yeah. So this is usually the most common syntax of writing a command at the command line. There are a few exceptions to this. For example, you may have a main command, then a sub command, and then arguments and options. So the best example for that is the git command. So in this case, git is the main command. As you can see, okay. So git is the main command. Init is the sub command for this particular command. Okay. Then git status. So git is the main command. Status is the sub command. And minus s is the optional flag. So there are some commands that have main command and then a sub command. So that is also a syntax that is possible. So that really depends on the command that you have. Okay. And lastly, another thing that you may see on your terminal is somewhere over here, like the tip of the arrow. In my case, I have customized the terminal, so you can't see that probably. But sometimes you see a $sign over here. Okay, sometimes there is a $sign over here. So that $sign is called the command prompt. And that is why I said there are two meanings to command prompt. One, command prompt is the Windows terminal application. The other meaning of command prompt is the $sign that you may see at the point where you are going to type the command. So what does that $sign indicate? So that $sign indicates that you are currently logged in as a non-root user. Okay. So now you may be thinking, what is a root user? So basically, the root user has some additional permissions with respect to executing some advanced or like some commands that are crucial to the operating system. A root user is just a user that has some additional privileges and has permissions to execute something that you do not have. So right now, I'm not the root user over here. So if I wanted to become the root user, the command for that would be sudo -i. And I'm prompted to enter a password. Okay. So now the command prompt has changed from dollar to the hash symbol. The hash symbol indicates that right now I am logged in as the root user. All right. So is this part clear? I can exit from the root user by typing exit and it says log out. And now I'm back in logged in as a normal user. So is this part clear? The whole part about the command line parameters and the syntax of the command?
Sir, if you have a doubt from Shivam,
Yeah.
he's asking how can I go to the folder using a cd command where the name of the folder contains spaces.
Okay. So if you want to go to a folder that whose name contains spaces, so okay, I'll show you. Let's say I create a new folder. Okay, so when you want, for example, if I do this right now, what this command will do is that it will create two folders, one called name and the other called folder. So if I want to like have a space in it, what I do is I use the backslash command. The backslash character is actually an escape character. So when the shell tries to interpret this particular command that I have written, it sees the backslash and then it knows that okay, the space next to it is a part of the name, it is a part of the argument. So let's try this. And okay, it still created two folders. Wow. Another way is that you can simply put it in uh, quotations. I don't know why this doesn't work. Okay, acha, it did work. Okay, so cd into this particular folder, right? Name backslash space folder. Okay, great. So you can see that we have used the cd command to enter a folder whose name has a space in between. You use the backslash command over here. Okay, so backslash is the escape character, and that is how you. Okay, another way would have been, if I go back, another way would have been to use quotation marks directly to specify the name of the folder as a string. Once again, we get the same result. So I hope this clears your doubt. Are there any other doubts?
Yes, sir. Chirag is asking, can you repeat once again the git parts?
Okay, okay. So like it's written here, most commands consist of the following syntax. That is, we have a command, we have an optional argument, and we have an optional flag. But there are some commands that follow the following syntax: the main command, the sub command, and then optional arguments and optional flags. So here in this case, the git command is the main command. Okay, and by itself the git command simply displays a help page that shows the common git commands that can be used in association with the main git command. So the clone, init, add, mv, reset, all these things that you see, all these commands that you see are actually sub commands where the main command is git. Then you can say git and the name of the sub command that you want to run. And if you have any arguments or any optional flags, so wait, I can explain this better. So let's say that you have git add as the sub command. Okay, add is the sub command, and now the full stop. This full stop is the argument in this particular syntax. So we have main command, sub command, and the optional argument. Let's consider another example. Okay, so let's check this command. Git is the main command, commit is the sub command, -m is the option or the flag in this case, and this one here is the argument. So that is basically how git commands have their syntaxes. So I hope this clears your doubt. Are there any other doubts?
No, I don't think there are any more doubts. We can proceed forward.
Okay. So let's now look at some basic commands. Uh, you can try this along with me if you want. Uh, okay, so the first command that we are going to see is find. So find, like I said before, you can search for files using the GUI, but now we'll show you how to search for files using the CLI. So find command, basically it searches for a file in a directory, and it can also be chained with other commands to execute some command on them. Okay, so right now I am again in the CLI Workshop folder, and I want to find if there is a file named uh, some file I need to find. So let's say, so we write the find command. Okay, then we pass in an argument, the find command, and an argument full stop, which specifies that we need to find in the current directory. Then an option name, that is we want to find using name. Okay, and then we need to provide it a pattern. So we'll get to patterns later, but first let me just find a given file. Okay, so the entire command is this, and you may not have a delete.txt, so it won't show you any results, but I actually do have a delete.txt. So the command is find, the argument is the full stop, signifies the current directory, minus name is the option, and this particular is a pattern that we provide, which is also an argument to the find command. uh, did I miss the code somewhere? Oh, okay, so upon running this command, we get the path to where this delete.txt file is present. So what this path says is that dot slash, which means in the current directory, there is a folder called find demo. Okay, so there is a folder called find demo right here. And inside that folder, the delete.txt file is present. So this is the syntax to find a particular file in a given directory. So when we say that dot, it means that it will search not just in the current directory, but also in any subdirectories of the current directory. Is this part clear? Okay, so now what if I want to find, let's say I want to find all the text files in the current directory. Like in that case, what will we do? Like we don't know what is the name of the text file, and we also don't know how many text files are there. So in that case, we use the pattern that we can provide over here. So the command for that would be, once again, find.name, and then we need to provide a pattern. So what does a pattern mean, or how can you write your own pattern? So let's just, okay. So what this pattern does is that it will find any file that has a .txt in its name. The star over here, okay, the asterisk symbol over here, that signifies that it does not matter what comes in this particular part of the pattern, but whatever names that you find should have .txt in them. So basically this asterisk is like a wildcard character. You can put anything inside it. For example, the star can have a value abc.txt, and that file will be found. If it has the name xyz.txt, that file will also be found. All right, so let's run this command. Okay, so I find all these text files that are present in the current directory. Like you can see, anything with a .txt in the end is found by this particular command. Let's say that, okay, let's try another command, another pattern. All right, so what this will do is that this pattern searches for the string delete anything in between, anything after delete, and then a .txt in the end. So when I run that command, so I get three files in the output. One of them contains _2 in place of the star. The second one contains _3 in place of the star. And the third one does not contain anything. So what the star here means is that you can have zero or more number of characters in place of the star, and it doesn't matter what those characters are, all those files will be found. So I hope the find command is clear to you. And this is just one thing that you can do with the find command. So if you, there is a command called man, which stands for manual. So basically, it's like any other electronics manual that you have. For example, a manual for your TV to see how it works. So just like that, we have a manual for commands to see how a particular command works, and it also shows the different options that you can use with that command. So let's check out find. Okay, so when I do my man find, it gives me a big documentation that shows what all things can be done using the find command. So basically, what it does is it walks a file hierarchy. Basically, it searches the traverses the entire file directory to see for things, find things, and then here is a list of options that you can use. So there are different options, and you don't need to remember everything, and most of the time you won't even use everything. There are just a few common options that you use most of the time. So there are tons of options present over here, and with the description of what they do. All right, so you get kind of like whoever made the find program, that person has written this documentation. So anytime in the future, if you have any lab assignments that require you to type commands, and then you need to make a experiment file out of that, and if you need theory for the commands, this is where you find the theory. So you can basically run man for any command. So let's run man for the change directory command, and you get the manual for the change directory command with the different options it has. So is this part clear? Is find clear? Do we have any questions?
We have a question from Atharva. In order to search in other directories, do we simply write that directory's name instead of the dot that you used?
Yes, yes. Yes, if you want to search in a different directory, you write the name of the directory. So for example, if I say find and then the name of the directory was this. Okay, so as you can see now, it will only search for the files. Wait, make it more clear. So before, when we ran this command with the full stop, it gave us lots of files. Now it will give only those text files that are present in this particular directory. So we get only 3 files which are present in this particular directory. So if you want to find something in a different directory, specify the path to that directory. All right. Any other doubts?
Next up, we have a doubt from Shreyas. He's asking, how do people code the find command? Do they do it in assembly language or bash?
Okay. See, that depends on the, like, there are different languages that provide you the option to write commands that run over the command line. For example, you can write commands in Python as well. So the presentation that you are seeing is basically run from a package called present that was written in Python. So there are even C++, Python, Java, all of these provide you with libraries that can help you to write your own command line programs. So there's no fixed thing, but I think since these commands were written uh, quite a long time ago, so I think these may be written in Bash, but I'm not sure about that. But you can use any language and try to find if there are libraries in it that help you to write command line programs. Okay, so Next command is sort command. So what the sort command does is that it sorts the lines in a text files. Okay, so let's see that. Let me go to. Okay, so in this directory, I have 3 files for 3 examples. So what the sort command basically does is that it sorts the output of the file. For example, if I run the sort command, it will not make changes inside the file. It will, what it will do is that it will read the file, sort it and print it to the command line. So okay, this may get confusing. So let's just see what's inside the sort1.txt file. So cat is a command that you can use to read the contents of a file. Okay, so in this sort1.txt file, I have some random numbers. Okay, I have some random numbers and I want to sort these numbers. So the command for that is sort and the name of the file as the argument. As you can see, we get the numbers sorted. But keep in mind that the original file is not sorted. Okay, if I do cat sort1 again, I'll still see the numbers in the same order. So the sort command does not modify the original file. Now, if you wanted to capture the sorted output, what you can do is you can store that output to a new file, sort1.txt, and use the greater than operator here. What this basically tells is that sort the sort1.txt file, and whatever output you get, you put it inside a different file. Sort3. So if I run cat sort3.txt over here, you can see the sorted output is now stored in a different file. So the sort command, it sorts the output but does not modify the original content of the file. So is this clear? The first example. Okay, you can, like in this example, we saw that we can sort numbers, but can we sort something else? So this file contains some random names, and these names are not in sorted order. So we can sort these by characters as well, alphabetically. So here you can see that the output is sorted. Can we sort them reverse alphabetically? So yes, we can do that. And here we use the -r option. So command option argument. So here you can see that the names are now sorted in the reverse order. So is there any doubt up till here? Okay, so now we have seen that we can sort numbers and we can sort the alphabets, right? The alphanumeric characters. Can we sort like tables based on something? So let's take this example. I have a CSV file which is pretty basic, just 2 columns with few entries. So column 1 contains some words and column 2 is some numbers. So let's say that I want to sort this CSV file such that the rows are arranged in a way that the first column is sorted. Okay. So first let me just run normal sort command on this file. So if I just run it this way, we see that the file is sorted and we get the first column is sorted, but the second column is not sorted. So the sorting has been done according to the first column. Now let's say that we need to sort based on some other column. So what do we do that? How do we do that? So here once again you have another option, and this time we have 2 arguments. Sort is the command, -k is the option, to and employee.csv are the arguments. So here 2 indicates that we need to sort based on the second column. So as you can see now, the second column has been sorted. So in this way, you can sort different files, and the best use case for this sorting a CSV file or Excel sheet would be that, like, You may have heard that we use the Chrome extension to get the attendance of lectures, right? So in that case, for example, if someone is not present in the lecture and then he needs to add his name to the sheet later on, if that is the case, and then in that case the sheet is not like sorted, so the extension records attendance in a sorted format, but people enter their names randomly later on in the sheet. So you can directly use this command to sort the sheet so that the teacher doesn't understand that we have tampered with the sheet. So this is just a use case for that. Is there any doubt with the sort command? In case you're wondering whether if we have 2 to 3 columns and we said we want to sort based on the first column, and if there was a match in the first column, then the sorting would occur or take place like, okay, so if we have 2 entries that are same in the first column, then to differentiate between those 2 entries, the second column will be compared. Okay, so is this part clear? So can you move to the next command?
So if we have a question, what is the -k option?
For sort,
Yeah.
simple, let's just read it from here. Do we have a minus k option?
The one you use for the CSV file. K,
Okay.
K for key.
Okay. So basically the minus k option, see here we can see that it is defined as a sorted key. So basically minus k means that we tell the command that we want to sort on a particular key. So key here in this case is the number of the column, the position of the column. If you want to know about any particular option, just use the man command and you can get all the information about the command. Minus k option means sorting based on a key. Any other questions? Okay, so let's move on to the CMP command. We'll do this one quickly. CMP command basically compares 2 files byte by byte. So what byte by byte means is that in a way it compares the byte code for the like how the file is represented in the byte format. So no need to worry about what exactly the byte format is. You can simply use this command to compare 2 files. In this case, let's compare the sort1.txt, which is numbers, so, which is words. Okay. So basically, what this tells us is that there is a difference in character 1 on line 1. That is evident from here. So there is a difference in the first character of the first line. Quite easy to understand. Okay, so CMP command basically compares 2 files. The last command is grep. Okay, this command is pretty useful if you want to search for particular text inside of a file. So what it does is it filters the file for a particular pattern of characters and it displays all the lines that contain that pattern. So basically, if you have a file and you want to check whether a particular word is present in the file or a particular phrase is present in the file, and then on which file, which lines is that present on. So you can use this command to do that. So I have one file here. So it contains 4 sentences, and let's say that I want to find the word Unix in this particular file. Okay, so we get the output as so the first sentence contains Unix, which is shown in the output, and where exactly Unix is present is highlighted. In the last sentence also Unix is present. Now you can see that this match that was made to find Unix it is case sensitive, as capital U wala Unix is not present in the final output, and this one with N capital is not present. So if you wanted to do an case insensitive match, the command for that is grep -i option. -i signifies insensitive, not case sensitive. Okay, so now here you get all the files that contain Unix, irrespective of what case of characters they are. Let's say that, okay, so I want to find a particular pattern. Okay, I want to find a particular pattern. Let's say I want to find any words that contain the word open. So here we get the output that we got open source is the word that contains the pattern open. So that means that you can provide patterns in here. And if you are aware of what regular expressions are, you can use regular expressions to create complex patterns that you want to search. If you want to search for, instead if you don't want that search to be like of patterns, but instead you want to find complete words. So for example, is there any word that is okay? Okay. What example can I take? Okay, so if I use operating over here, I get this particular line as the output because it contains operating inside it. All right. But if I did OPER, right, still this line would be as a part of the output, because we are finding based on the filtering based on the pattern. But instead, if you wanted to filter based on words, like for example, if I add the W flag, which signifies that filter only if that particular match is a complete word. Okay. So we don't get any matches here because OPER, this particular word is not present in this file. So is this part clear? You can use grep to find and filter things within files. Is this part clear? Okay. So next we have okay. So fair warning, these commands, remote login commands, are quite advanced. So they require actually a lot of setup. We too had to put in around 2 hours to properly set up the following example that we are going to show. So the remote, okay, you can use the command line to access a different computer altogether. So you can use what is called as SSH. It stands for secure shell. What it exactly means is actually quite complicated, but all you have to know is that it is a set of commands that allow you to access remote machines. That is, you can access computers that like remotely. You can access computers that are like okay on different networks. So, and that connection that you make with a far away computer, it is secure and it is encrypted. So basically what this means is that if, for example, right now I'm sitting at my home, I'm logged into my computer, but I have some files in my college computer. So let's assume that we all have a computer for ourselves at college. So in that I have some files and I need to get those files. But those files are not on Google Drive or anywhere, so I don't have any cloud access to that. In that case, I can establish a connection with my college computer using SSH, and then I can transfer files and data between the two computers. And the data that is transferred is encrypted. So basically, SSH provides a way to connect to a different computer. Okay, so why would you need SSH? Uh, First of all, let's say that we are responsible for controlling a nuclear reactor, and in that case, the radioactivity in that region is too high, so we can't physically go over there and manage the systems in person. So in that case, we can simply remotely log into that system and control it. This is just an example. So in any use case where you would require remote access to a different computer, this SSH command can be used. It can also be used for interactive and automated file transfers. Then issuing remote commands. Okay, so let's say that I am on my local machine and I want to, I have a server that is running somewhere in the cloud, and I want to execute something on that particular server. So I can do that using remote login, and then I can execute commands remotely. SSH is very useful in managing network infrastructure and other mission critical system components. So, okay, is this part clear about SSH, what it does? Okay, so we are going to show you a demo of SSH. I am going to log into Parse computer from here. So let me first show you that right now I am logged in as my user on my own computer. And let's say I want to log into Parse computer. So for that, the command is SSH. Then the username that I want to log into in that remote computer. So for example, if I want to log into Parth's computer, the username that I'm going to log into is called Parth @ and then I need to provide the IP address of the device. That is the public IP address. Now, if you're not familiar with what IP address is, it's basically a networking term that we won't be explaining what it exactly means, but you can check that up. So here I have the Parth's IP address. So, okay. So now I have tried to establish the connection with his computer, and it is asking me to enter a passphrase. So this particular passphrase is what ensures that I am connecting to the right remote device, and also that I have the permissions to connect to that remote device. So I'm going to enter the passphrase. Okay, so now you can see that the prompt has changed and I am inside Parth's computer right now. Let's see what files Parth has. So Parth has all these files over here. File type. So as you can see, before it showed my name as the user, and right now it's showing Parth's name. So basically what I can do is that right now I am not a root user, so obviously I can't use any super user commands, but I can run different commands in Parth's computer. So for example, I can go into the CLI Workshop directory. I can display the contents of that directory. And can even, okay, so you can run different commands basically remotely. So let's rename something. I'm going to rename that JPEG file. So as you can see, I have entered, I've logged into Parth's computer and I have renamed his file. So in this way, SSH can help you to have remote access to a different computer. So along with SSH, there is also a tool called SFTP, which allows you to securely transfer files between two remote devices. So it's a very cool command. So as you can see, I have Mac OS, but Parth has Arch Linux. So right now I'm inside his account that is inside his device. So if you want to exit SSH, you can type exit and the shows that connection has been closed. Let's try SFTP now. So SFTP is another command. It stands for Secure File Transfer Protocol. Okay, so sorry. I had the wrong address. Wrong IT. Once again, it asks for the passphrase. Okay, so now I'm connected to his file. Now SFTP can be quite confusing if you look at things here, because if you want to see the files that you have on your computer, like, so the command won't be ls, it would be lls, which means that local, the first L stands for local and then the name of the command. So if I type lls, it will show me my files. Okay, if I only type ls, it will show me paths files over here. So if I want to go to the CLI workshop directory, I'll have to type cd. That is, cd will stand for change directory in the remote device. Once again, if I do that, I'm inside another device. So, okay, let's say that I want to transfer this presentation m.md file from Parth's computer to my computer. Okay, so I don't have that presentation.md file. Command would be get presentation.md. Okay, if I run this, I make a spelling mistake. Okay, I made a spelling mistake. See, it shows that it has copied the file, shows the what the progress of the file and the speed and the estimated time to get the file. Now, if I do LLS, you can see that I have got that file. So SFTP can be used to transfer files between two remote devices. And if I had root access, I could pretty much delete anything I wanted from here, but I don't. Okay, so is this part clear about remote login? If you have any doubts, please ask.
Yeah, there are a few doubts. So the first doubt is by Vishal. Can we write or delete remote files which we accessed?
Yes, you can write and delete remote files, provided that you have the read and write permissions in the for the directory in the remote device. So, for example, if I did not have the permissions to create a new file in the downloads folder of the remote device, then I won't be allowed to do that. So basically, you need to have permissions just to do things just like you have on your own device.
Okay, and the next question is about the passphrase. So where can you find the passphrase, and is it the same as the local password?
No, the passphrase is not same as the local password. And what the passphrase means is that when you set up SSH, okay, so when in this scenario, my device is the SSH client, whereas Parth's device is the SSH server. So in order to establish a connection and to verify that this connection is valid and authorized by both the parties, we need to create what's called an SSH key. So that is another complicated setup thing that you have to do. So once you create that SSH key, so while creating that SSH key, you need to provide a passphrase. So that is the same passphrase that I have typed. So when we were setting up and we had to create an SSH key, so at that time, the passphrase that I used was the same passphrase that was required for me to enter while connecting to the SSH server. So during the process of setup, you create a SSH key, and at that time, you create the passphrase. Now, the passphrase can be anything that you want. It does not have to be the login password for either the local device or the remote device.
Okay, so the next doubt is, so the LLS command is displaying the contents of your computer or Parth's computer?
LLS is displaying the command for my computer, because the first L stands for local. So if I wanted to do change directory in my own device, I would do LCD rather than CD. So that is how it works.
And the next question is, we have IP address for Android as well. So can we control Android phones also?
No, you cannot control. You cannot control Android phones because they don't run the SSH server or the SSH client. So if you somehow installed the SSH client and SSH server and then executed commands from there, then only then will you be able to access that. So no, you cannot access Android devices this way.
So yeah, this is not a hacking workshop, guys. Please don't hack
Yeah, and
our.
this is not hacking. Okay, this is not hacking. Because both the SSH client and the SSH server have mutual consent for access, and that is why they were able to create the SSH key. And the SSH server specifically has permissions, like it establishes permissions on directories and operations that a particular local device can perform on that remote device. So this is in no way that people are hacking anything. Okay, one last thing before I stop. Yeah, so people were asking that why did we ask to install WSL? That's because the commands that we run on right now, they do not work on the default Windows terminal. So in that case, we asked you to download the WSL for that. So that basically provides like a subsystem for the Windows where you can run the environment for the different Linux distributions. And the case that in case you have a Mac, you weren't supposed to do anything. That's because you don't need to do anything. Pretty much under the hood, like if you go deep into operating system concepts, the kernel for Mac OS is Unix, and which is very similar to that of Linux. So that is why no additional steps were required to be done for Mac OS. So with that, I conclude my part, and next, Bhavya, you can start.
Yeah, just before that, there are a couple of doubts. So if you could just solve them
Okay.
yourself. So yeah, the first one is like, is TeamViewer based on this SSH concept?
I don't know. I'm not sure about this, but most probably it is based on some remote access protocol. So, in under remote access, the field of remote access is quite big, and there are different ways or different protocols which have been established in remote for remote login access, of which SSH is just one protocol. So, definitely TeamViewer will be based on some remote access protocol, but I'm not sure whether it's exactly SSH.
Yeah, and actually, can you check the Meet chat, because there are quite a few doubts.
Oh, is cloud computing dependent on SSH, or is it the implementation of SSH? So cloud computing is a different domain altogether, but the way you can access the servers in the cloud, one of the ways is using SSH. So basically, cloud computing is completely different, and one of the parts of cloud computing is accessing the remote devices that can be done using SSH. Yeah, AWS uses SSH configuration. That is correct. Is it possible to trace unauthorized login attempts to SSH server with date of intrusion along with their corresponding IP addresses? Um, I don't know whether this is possible, but one thing that I can tell you is that if the SSH key does not match, or the passphrase is incorrect, or the IP address of the client is not already like whitelisted by the SSH server, then the server will straight away reject the connection request. So in that case, if we can modify it, like add something to work with SSH, then we can probably log every client that is trying to access the SSH server. If you SSH, will it affect Path's workflow? No, he doesn't even realize that I have SSH'd into his device. He can use it normally like he wants. Can this server see what all commands are being run or changes are being made? So no, right now when we performed this, Parth wasn't aware that SSH was running. So the server does not see, but I think there can be done something about that so that the clients, SSH clients, can be monitored. So, okay, we have spent a lot of time on this. So, Bhavya, you can start presenting.
Okay, so we looked at the basic commands of CLI and how we can remotely access someone, a server, and a server, a remote server using SSH. But now let's actually look at our own PCs and look at the Linux file configuration. So just a second, I'll start my presentation. Okay. Um, so Okay, so the Linux file system, what is it and why is it used, and what was the brief history behind that? So let's take a look at all that. But first, why do we need to learn about the Linux file system? So first of all, like if any of you have tried use Ubuntu or some other Linux distro and have tried installing some package, for example TensorFlow or something, you may often have run into errors while installing. And a lot of them can be solved by actually changing something in the file system. So although it is not recommended to actually manually change stuff regularly in the file system because we have package managers to do that, but it can help a lot in debugging stuff. And that is why it is necessary to have a basic idea of why we need to have some knowledge about the file system. And next is it helps while setting up SSH servers and working with cloud, etc. So though we didn't show you the process of actually setting up the server on Parth's desktop, but a lot of it does involve some knowledge of the file system. And third point, it feels really cool. There is a lot of jargon behind it, and when you say that stuff, it feels really cool. Okay. Yeah, so moving on. So what is a file system exactly? So what do we mean when we say the Linux file system? So as we know, the RAM is the main memory of our computer, and that is what the CPU uses to get immediate info about all running processes, etc. But however, we cannot use RAM as a non-volatile storage method. So we have to implement a non-volatile storage method that deals with the OS booting, file storage, and all of that. And that is why we need to have a file system, and that is one of the functions of the file system. Second, it is used as a communication method between the kernel and the hardware. So let's just take a look at an image here. So I hope you can see this image. So this ext3, HPFS, VFAT, all of those are different file management systems, and this is the virtual file system. This is the that Linux uses. So this is like a two-way file management system where the virtual file system is the actual tree structure that we see while we open the file manager, and this is all the behind the hood stuff, the actual implementation method it uses to implement file systems. And so this forms a sort of a gateway between the hardware and the Linux kernel. So the hardware actually has the data stored on it as a series of bits, and to send that data to the kernel, we need a file system in the middle. So yeah, I think that is what the file system uh, uses. Then the next one is it defines a namespace. So naming and so a namespace is basically just a naming method. So previous old file systems, they had very primitive naming systems. So you could only have like file names up to 250 16 bits, 255 bits, and this severely reduced the amount of memory that you could address. So this is one of the roles of the file system. And the next up on the list is define security rules. So as Seth mentioned previously that CLI, a lot of the CLI commands, they can only be run using the using root privileges, using the sudo command and that. So a file system actually implements those permissions into the kernel, and that is what the CLI uses to determine which users to give access to and which to reject. All right. So let's just take a look at a brief history of the file system, the Linux file system. So currently Linux uses the ext4 file system, and the first version of that ext4 ext, it was based on the Minix file. So Minix is actually a very old OS that was based on Unix, and it came out way back in 1987, and it could only address up to 64 MB of data. So as I said, this is a problem that old file systems used to have, and this is what the namespace deals with to actually make sure that bigger amounts of data can be addressed. And to solve these problems, the Linux community built ext. So let's take a look at what ext actually is and how it implements stuff. So if you could just quickly run this command in your command prompts on the WSL terminal or on the Ubuntu terminal, we can get started with this. So yeah, I'll just give you 2 minutes to do that. Okay, so okay, let's get started. Did all of you install that this package, the tree package? Just put a yes if you did in the comments. All right. All right then. Let's start. So
Just a minute, Bhavya.
if I
Bhavya,
just
just a minute.
yeah,
One of us has an error, unable to package packet tree. Would you help it?
unable to locate package tree. Okay. Are you using WSL2? Okay. Can you try this with apt get instead of apt? Yeah, we'll get to the difference between apt and apt get in some time. Okay. Yeah, try sudo. Uh, Actually, it's okay. We'll have a look at the error later, but because we have like time constraints right now, तो वो देखते हैं बाद में. But for now, you can easily follow. It's not very complicated. It's just a small command, and you can easily follow it on the screen. So yeah. So if I just do tree and this, it lists all the files in my system, everything on all levels of dev and all. and this will just keep on going on and on. So let's just stop this. This is not very useful. And to actually get a look at the root directory and what it has, we'll use this command. And so, as Steph mentioned in his explanation, tree is the command, and this is these are minus L is an option, and these are the arguments. So the forward slash actually represents the root directory of Linux, and the one denotes the depth. So this is the root directory of Linux, the forward slash, and all these directories are at a depth of one on the file system. So this has everything, and Linux has a slightly different way of storing files compared to other and an operating system like Windows. So Windows uses the NTFS file system, and NTFS has separate drives on which you can store data. So it doesn't implement a single tree like structure like Linux does. So you have C drive, D drive, E drive, etc. And the basic OS info can be stored on C drive, but you can store the other personal files and other user files on D, E as well as C. So Linux has something similar, but not quite like it. So it implements a single tree structure where root is the okay, yeah. So moving on. Yeah, sorry about that. So this is the first level, and let's take a look at what the each of these directories does. So bin has the binary files that the system stores uh, right here. So it stores them as executables, and actually let's have a look at the bin system. So this is bin right here, and if you see this, you can actually make out commands that we use on the command prompt. So ls is one command. So ls is one command right here, and similarly we have a lot of commands that the system uses, and we store them as binary, like as in a executable format. So if I just open up the ls for file here, you won't be able to make out anything because it's not in a human readable format. So this is actually something related to how so when you compile a C++ file or a Java file, you get an executable, and it is in a similar format to this. So this is the executable, and it has its representations in an octal format, but it is not human readable. So that is what the bin folder does. It has binary executable files. Now boot folder. Now the boot folder has the boot files. I think it's pretty easy. It's pretty self-explanatory. But boot folder has the boot files of the OS, and that is what the Linux system uses to actually boot itself up. And whatever you do, don't mess with this because it'll something will go wrong. So I'll just show what the boot file system looks like, and this is the grub, this is the bootloader for Linux, and EFI is the actual storage, the EFI disk, and but never mess with this. The CD-ROM file is the driver files for the CD-ROM, and because I don't have a CD-ROM on this machine, it's currently empty. The dev files has all the device driver files. So if you attach a new mouse to your laptop or something like a webcam, so all those device driver files will be saved right here. And etc files, what the it's it so although usually it's like etc, but to fill all the miscellaneous files, but the name is misleading. It is not that. So what the etc file store is, okay, so it has all the software executables. So right here you can see the Python files right here. Then there is an R file right here. Then Postgres. So all the package manager basically deals with this. So you don't have to manually populate this folder. But when you use a package manager like apt or apt-get, it stores its files in these folders, and these are actually shared libraries. So all the programs that may use these binaries, they are available between all of them. And lib32 and lib64, they are so this is a very variable system. And libs, they also have software libraries, like, so yeah, the firmware and stuff like that. Now moving on, let's so lib32 and lib64 are basically the 32-bit and 64-bit variants of the library files. And media media and mount are actually similar. So when you mount a new directory to an endpoint of the system, those files are stored in the media and mnt subdirectories of root. So media has actually my the phones that I've connected that with. So it has all those information, all those data. And because mnt is kind of an older version of media, and it has been, not, I wouldn't say discontinued, but it has been redirected to this. So one reason that this hasn't been discontinued is just removing this directory can cause breaking changes in the Linux code base. So what the developers have instead opted for is redirecting data from mnt to media. And opt, yeah, so opt is also it stands for optional, and it has data that the vendors can install on the pc. So something like android studio files, or your nvidia drivers, or something like a pycharm ide, those details are stored here. Proc has all the processes are running over here. All of this is running processes on the pc, and that is what proc actually does. And run, so yeah, linux uses a host of background daemons um, to provide all the services. So if, for example, you have slack running in the background, or if you have something like discord running in the background, those daemons are stored at run. And sbin, okay, sbin is the super user binary. So for this bin, so currently I'm the only user on this pc. However, if I have a guest user and I don't grant the guest user super user privileges, he'll be only able to access the binaries in the bin file. And I will be able to access binaries both in the sbin, that is the super user binary files, as well as the bin files. And snap is it stores the snap packages for the ubuntu system. So as you may know, ubuntu has been heavily pushing to install snap packages from its store. So if you install those snap packages from the ubuntu store, so something like pycharm or postman or heroku, so all the snap packages that you install from the store, they are stored right here. The server srv, so yeah, this is quite interesting. So so we just saw the ssh demo by Saif and Parth. So if you actually look at the srv folder on Parth's computer, he'll have a www/ssh folder, uh, where it stores the details of the public keys and the ssh keys that the server is using to grant access to remote users. So this is what SRV stores. TMP is a temporary log sort of system, where it stores all the temporary files that the OS generates as the user goes about his tasks. And user again has some user info. for again it has some binaries and super binaries and stuff like that. And the final one is where again something like your backups and local files and all of that is stored. So yeah, this was like a basic sort of boring introduction to the directory structure in Linux. But how does this actually store? So we saw that this has a tree structure. So you can see the nodes of the tree right here. But how does it actually implement this? So um, if you see this image, so this is basically a snapshot of what we just saw earlier. So this has all of those the tree-like structures that the Linux file system uses. However, the computer doesn't understand trees or tree structures. So how do you tell the computer कि हाँ ये tree है, इसका ये node है, इसका ये child है, and stuff like that. So it is similar to how we implement a binary tree. So if you have some basic idea of a binary tree, so the node has a root node. So it has the value of the node itself, and it has two pointers, left child and right child. So the computer understands pointers and addresses on the memory, but using those we indirectly implement a data structure, a logical data structure. तो लिनक्स में भी वैसा ही होता है. आई नोड करके एक नोड है फॉर लाइक ईच टाइम अ फाइल इज क्रिएटेड वी हैव एन आई नोड. So an inode is created for that file, which has details like which directory it's in, the timestamp that it was created on, and stuff like that. And using that inode, the virtual file system, this component right here, the virtual file system, that actually abstracts all of that info and shows it to us in a tree format that we can understand. So this was the basic information about the Linux directory structure. And yeah, it is a lot of theory and a little bit boring, but it is important because let's say you are implementing a cloud server, a server on cloud, and you need to transfer files and you need to install some packages on the server. So how do you do that? Sure, you can use a package manager, but in case some errors pop up or in case you need to manually change something, having some knowledge of the file structure is very important. So yeah, I think that concludes my part, and Parth will explain to you the different package managers. So Parth, over to you. Are there any doubts? Okay, no. Okay, Parth, over to you. Thanks.
Thanks. Is my screen visible?
Yes.
Okay. Okay, so this is an introduction to package managers. So first, let's look at packages. So packages are simply an archive that contains the binaries, which are the executable files of the programs. It contains the configuration files of like how should the program be configured on the system, and it includes the list of dependencies, like what does this package depend on. So yeah. So what is the need for package managers? So software was pre-package manager era. Software was usually compiled from source. It still is, but package managers make this easier. So this is a old project. So if you look here, you have to compile this program to install it on your system. And yeah, and if you need to install these dependencies manually on your own. You need to install each of the dependency. Then only will you be able to compile this program. So that is a very tedious job to do. So you have to manage the dependencies on yourself. You have to compile the program from the source code, and if an update comes, you need to recompile the package. So that is where package managers come in. They basically handle the management of packages, from installing the package to upgrading it and to uninstalling it. Everything can be just done through one command using package managers. So there are different types of package managers. In Linux package managers, you will find apt and dpackage being used for Debian-based operating systems, and RPM and Yum used for Red Hat operating systems, and Pacman used for Arch-based operating systems. You even have language package managers, which you will all be familiar with, npm and yarn for Node.js, and pip for Python. So these are the different types of package managers. Let's look at package management in Debian or Ubuntu, to be specific. So in Ubuntu, you will have a program called dpackage, which is a low-level package manager, and you have apt, which is a high-level package manager. So to explain low-level and high-level, I have a program here. I have a picture here. So a low-level package manager, what it does basically is it directly interfaces with your Linux system. So dpackage will directly handle the installation and deletion of deb files, and apt will act as a wrapper. It will use dpackage, but it will provide easy to use commands, so you don't have to like directly touch the Linux file system, as Navya said, which you should not do. So yeah, so these are packages basically. This is a Debian package, so this can be installed only on Debian based systems, and this is a tar.gz archive. This is basically the source code, zipped compressed source code, which you can install on Arch Linux kind of distributions. Yeah. So okay, so someone had asked. Okay, so someone had asked that what is the difference between apt and apt-get. So so yeah, that difference is basically apt-get is a collection of a couple of different commands. So to ease using the command line package manager, the developers developed apt. I can show you. Yeah. So if you look at this table, apt-get and apt have almost the same subcommands. The only difference, if you see here, is you use apt-get at some places, and some places you use apt-cache, like for searching or showing the package details. So to club all this under one command, we use apt, and you can use both of them on your system. It's your choice, but apt is much more easier to use. So yeah. So these are some common commands which you can use on your system. So if you want to search for a package, you just do apt search package name. So if I just search, and it will fetch the search result from the Ubuntu repository. So here you can see it has got this. This is not installed on my system. I'm just searching it in the Ubuntu repository. And to install this package, you just run sudo apt install and the package name. It will ask you for a password, and you can just install it like that. And there is also commands to uninstall packages as easy as this. But what this will do, the sudo apt remove command, is it will only remove the main package. It won't remove the dependencies, which is automatically installed when you are installing the package. So one important difference between apt and dpackage is that when you install a package using dpackage, it won't install the dependencies of your package. The dependencies will only be installed if you install the package via apt. So one more important reason for using only apt to install packages on your system. And let's see if that is done. Okay, so that's not done. So you can even see the details of a package using apt show. So this will give you all the details of the package, how it is installed, what repositories it's fetched from, and all. To update all your package links, you just run sudo apt update, and this will update your links. And basically it is checking if any package has been updated, and then if you want to see which are the upgradable packages, you can just run apt list and give the argument upgradable. So I currently do not have any upgradable package, but maybe you will be able to see it on your system. And like when if you have any upgradable package, you can just run sudo apt upgrade to upgrade your system. So just waiting for this. Oh, yeah, this is done. So now we can okay, so now we can use this program normally. And if you want to remove this program, or first let's look at the dependencies used by this program. So yeah, so you can look at the dependencies here. And if you want to remove this program, you just run sudo apt remove and the package name, and this will remove the program. Yeah, and if you want to just remove the dependencies also, so you just run sudo apt auto remove, which will remove the dependencies. So the, if you remember, I had shown these dependencies in the package information. So it is right now using this command, it is uninstalling these dependencies. So and basically, like if you want to look at any commands, so you just run apt help, and it will give you a list of the commands. So yeah, that is very useful. Instead of searching around or asking for help, you just do apt help, and it is pretty straightforward. So yeah, that's it. Are there any questions? Okay, so is apt a wrapper for apt-get? Yeah, you can say it is a wrapper for apt-get. They're both different programs, but yeah, apt like consolidates all the programs which apt-get has under one umbrella. What will auto remove? So as I said, each package has some dependencies, and when you run the sudo apt remove command, so when you run this command, it will only uninstall the specific package. It won't uninstall the dependencies. So to uninstall the dependencies, they are unused because you have uninstalled the package. So you just do sudo apt auto remove and it will remove all the unused dependencies in your system. Are there any more doubts? How to downgrade a package? I do not have any idea of that. Is there anyone who knows that? Okay, then. Okay, yeah, you can. Yeah, this is a good solution. You can uninstall the package and install the specific version. So if you write in front of the package name, if you put a equals to sign and the version, then it will install the specific version. So, Shubhankar, you can take over now.
Before we wind up, Parth, we have one last question from Dhairya. Does auto remove removes upgraded dependencies as well?
What do you mean by upgraded dependencies? Auto remove basically removes any unused dependencies. So if no other program depends on that, it will remove it. Okay, SKG, I think you can take over.
Awesome. Thanks. Good evening, everyone. Before we start what's in store from my side, I would like you all to run two commands in your terminal and I'll be typing them in the chat box. And we'll be waiting for 2 to 3 minutes for people to get on. And then we'll start with my session that covers piping and IO redirection. So I'll be typing the commands. Okay, so there's one installation part that's we're installing JQ. JQ is a JSON formatter. We'll see why that's used. The other part is cloning the inheritance repository. Like it's because like so that we can work on common platforms throughout. And so let's wait for a minute or two so that people finish cloning the repository and finish installing. And if you have any problems, you can like unmute yourself. You can unmute yourself and also you can mention in the chat box. When you're done with all the commands, you can just type yes in the chat box so that I'll be aware that you are up to sync. Okay, so it seems like people are on track. So we'll start. So I'll be covering piping and IO redirection. So what is piping? What happens is there are numerous commands. There are numerous commands on the script that give you an output, right? And there are numerous commands on the script that take in specific inputs as well. So what piping allows is you can take the output of one command and put it into the input of another command. So the pipe there acts as a form of transfer. So if it's visible on the screen, you will see that there's command 1 followed by the symbol for logical or and followed by command 2. What that does is it will take the output of command 1 and put it into the input of command 2. How that helps is basically there may be times when you may need certain specific command sets, and like it's not always feasible to write bash scripts to find out stuff like that. In that cases piping is useful, and there might be certain cases where in default commands won't be required, and may not be of use at all to you, and you will have to write your own commands rather than sitting down and starting from scratch. If we can if we can divide our task into chunks, then we can use the piping feature of what should I say, the Linux kernel, to help you gauge better. And like it helps to redirect. The point of piping is to redirect output from somewhere into the input of another command. So with this, let's not get much into theory, and so we can start working hands-on. Just to be sure everyone is in the same directory, just type pwd once, and while the entire path might be different, you should be inside inheritance 2020. So um, once you are in there, we can begin. If you're not in there, just do cd and get into that working directory. Okay, so let us do an ls. As you can see, there are multiple markdown files which you guys have written, and all of those are excellent. Now what we can do here is, the let's say the task that we want to do, the task that we want to achieve here is to sort all the markdown files in decreasing order according to the size of the markdown files. So
Shubhankar, you aren't audible right now.
yeah, am I audible currently?
Yes, yes.
Yeah, apologies for that. I faced a light outburst. What point did we last finish?
We were on
Can any?
something related to sorting.
Okay. So yeah, apologies everyone. So what we want to cover today is, this is a task that we have in hand. You can see there are multiple markdown files here. We need to sort these markdown files into we need to sort based on the memory that they consume, or in other words, the size of the markdown files. Now as far as I remember, there is no specific command that allows you to do so. Surely you can script it out, but let's see if we can achieve the same through piping. So before we begin, just just type ls minus l. So you can see there's a bunch of other information as well. ls minus l gives you 9 columns. Okay. So the 9 columns are, there are different permissions, owners who are able to access, and on the fifth column you can see the size consumed in bytes. Okay, so this is something to consider that we might be using here. So now what we will do is we'll take the output of ls minus l and we'll pipe that into grep command. If you remember, grep takes a current working directory into consideration and it finds out files that match something. So I'll be matching markdown here, so the md keyword, and if we do ls minus l and then we pipe it and grep md, so we'll see that we have matched all the markdown files that's needed here. Now, while this doesn't look interesting at all, let's say if there were any text files here, those would have gotten ignored. Okay. So people on sync up to here. Can I get a yes, no in the chat box? Okay, awesome. Let's try to extend this feature. So we had ls minus l, grep md. Now we will do some pretty printing. So there's an awk command, so that allows you to print specific columns and into specific regions that you wish to. So just you can just type out with me. So that should get all the file. Okay, just give me a moment. Yeah, apologies for that. So I'll type the command again. So that's ls minus l. That's piped into grep, and the searching pattern here is md. The output of that is piped into awk. Awk is a inline utility tool that is used for pretty printing. And look at here that we will see that there is $5 and $9 here. So the $5 and $9 stand for the command, like the column numbers, sorry, the column numbers that we just found out. So the fifth column indicated the memory size and the ninth column indicated the name. So so now you can see that indeed we have filtered out some of the data and we are on to regions that we need. So now that we are up to here, let's pipe this output again to the sort command. Okay, so I'll get the flow again. First, ls minus l lists all the files and gives a verbose output of many different contents. The point to note here is that it contains 9 columns. Next up, we use the grep command. Grep searches for files that have the md word in it, so that's all the markdown files in it. We pipe that into awk to pretty print some stuff. This helps us to filter out some certain stuff that's needed. We pipe the output of that to sort. And once we are at sort, we can see that based on the, what should I say, the memory consumed or the size of the file in bytes, all of our markdown files are sorted out. So there's one last thing to note about the sort function. This is not related to piping under any circumstances. And the point to note here is that sort takes functions in strings. Okay, sort compares string values. The reason why this did not matter here, because if you see 1 1 7 9 2 1 2 1 2 3 2 3 and then again 2 4, everything is not only in mathematically ascending order, it's also in lexicographic ascending order. So sort is comparing strings here currently. So just in case we are sure that the size of a file is always in memory and that's always a number. So we can always pass the -n flag. -n sorts keeping in mind that the part that we are sorting for is in numbers, integers. You have the same output, but yeah, it compared through numbers. So people on sync up till here. Can I get a show of yes? Okay, people are getting on track. Okay, did anyone face any problem in between? Uh, okay, so I think that people have like performed the first task. Now the second task that okay, just one final thing before we end out for this part. Sorry. Uh, Remember that we have a head and a tail command, so that just keeps the output simple. So we might want to use it sometime later, so just keep that in mind. Okay, so now that that's done, let's move on to the second task. So like before we start, I want to show you all something. So public APIs. Okay, so people just from the open source world who just finished on Sunday. This is another awesome website. We are not interested with the website currently, but there's a curl command here that I would like you all to enter before seeing the results first. So I've pasted the command in the chat box as well. Uh, I would like all of you to just print like paste the command in your command lines and see for yourself the output. Okay, so Dhanishta has a doubt that so head and tail is sorting according to alphabetical order. No, it does not. It does not sort. Basically, what it does is it takes out the first five, and it takes out the last five. In last the parameter that's needed up to that. Okay, so have people pasted in the command and press the enter button? Okay, so this must have been the condition for your terminal as well. Garbled JSON output. Have people actually typed that command? Okay, people are typing in yes, and I'm pretty sure once you enter that command, it's going to be garbled. Okay, now this is where the JQ comes into picture that we just installed. JQ is a JSON formatter. So what it does is what you saw right now was JSON. Okay, it's garbled, but it's JSON. What we will do is pretty print the JSON. So we will take this input and uh, Okay, so did people follow the command? I'll just keep that out. So it's the last command that you type. Um, then you piped it on into JQ followed by a dot operator within expressions. Once we are here, this shows the power of JQ. Like, this is not like related to JQ at all. But what I wanted to show you was JQ takes in input through pipes specifically. Okay, so like there are special formatters out there for some special keys such as, for example, GH and think so you will be you have might be installed, but GH is the GitHub CLI script. Okay, so like what this will happen is this does the pretty print formatting on its own. So like here we don't need JQ at all, but for regions like this, the curl API that I just gave you, we will need JQ. Okay, so are people caught up? Okay, Dhruvi has a problem. URL. Ah, yes, GH should not be installed in your. I just mentioned that it needs to be installed, so you can do it. Sudo apt install GH. I just wanted to show you that GH does the pretty print formatting on its own, while for other regions you might have to use JQ. Field writing body. Did you try it again, Dhruvi? Because I think this is more of an internet issue. Rest of the people, have everyone tried? Okay, now that we have some yeses, we can move on to the next part of my presentation, and that is IO redirection. I'll stop it and let's start again. So, what does IO redirection mean? So, if you see everything that you see on the out as an output in the terminal, that is in terminology terms, it's called STD out. It stands for standard output. Okay. Whatever you type into the terminal, that goes into std in, so that's standard input. And finally there's one place that we don't venture out, like not usually, that's std error, that stands for standard error. So these are the three main parts of any terminal. The one where you put in input is the standard in, the one where you see the output is standard out, and the one where error gets piped to is standard error. So these are the places where all of our inputs that we have seen. But what if you need to change these standard points? Like for example, let's say you have a result that you generated just now, and you want to write that into some file. So in those cases, we use IO redirection. IO redirection generally works through two very special characters, the lesser than and the greater than symbol. And so let's say in action, like before I'll just complete the theory. So when you are using single greater than and single smaller than symbols, what it does is it overrides. So whatever you paste on the right, whatever you do on the right hand side, it will be overwritten. So you can see the general structure that if file exists, overwrite to file. So all the contents of the file that you mentioned will be deleted and a new version will be created for it. And else, if the file does not exist, then it will just write on to the new file. Okay. The characters that overwrite is the greater than symbol that is used to override the standard output. So whatever output you might have been getting through your terminal streams, that will get directed to a file, and the file will have those contents. The lesser than symbol, that is like overwriting std in. So if you're giving input through the terminal, you can then redirect it in using the lesser than symbol. And the two greater than stands for overwriting standard error. This is not generally used, but like some cases people use it to silence the terminal, and that's where this comes into picture. I'll cover the theory part first, and then we can go on to the hands-on. Next up, we have the double greater than and the double lesser than symbol. C++ programmers would recognize this immediately. So where the difference here is, if the file exists in this case, it will append to file. It will not overwrite the file. It will just append to the already existing file. Or in other cases, if the file does not exist, then the behavior is same. It will create new. It will create a new file. The usage of the usage of the two characters are same as well. So a double greater than symbol will override the standard output. Lesser than symbol will override the standard input, and two followed by two double greater symbols will override the standard error parts. So this is just basic theory of how you can redirect your output and redirect from where you can take your input. Now we can jump on to the hands-on. So if you're in this repository, you can just leave out, or you can just do it. You can do it in another public directory as well. See the last command that we typed for like finishing our task here, the ls minus l, then followed by the pipe and multiple pipes. So if we can press this output, if we can just go to this command again and press enter, you can see that there are like 5 outputs here. Now what I will do is I'll redirect this to head.txt. So as you can see, there is no output here. But if I do a ls here, uh, where is it? You can see that there's a head.txt file already present, and if we can open that file, if you can open that file, you can see that we have five files in here. So I want people to try this out as well. So just let me know if you can try this one. Just after, can you please retype the commands? Okay, so you don't need to type the entire stuff every time. Just go onto your terminal and you can use your arrow keys. So the upper arrow key can get you to the last command, and then so and so. And instead of the head -5 pressing enter there, you can just write the greater than symbol followed by any file name that you wish to. So um so let me know if you can see the file on the output. Just like mention in the chats if you can see it. It didn't give any output. That's right, Zanishta. It should not give any output. When you redirect something to the file, the output of that should get stored in that file. So you can try opening that file. Yeah, there are many commands to list out the contents of the file. You can use any text editor or any like format. Okay, so this part is clear. So notice that I'm doing the same thing again. Echo is a keyword. Echo is a command that will just output whatever you type next to it. So it's the same that if I do hit 2.txt, I'll get hello world. Okay. So now, did people see this command? I used echo hello world followed by head2.txt. So the contents of head2.txt was hello world. In the third command, what I did was I typed a random command that's not echo. That's a weird call. But I was also redirecting the output here as well. So what happened here? When you pressed cat head2.txt, you saw that no output was found. So I should like this is what should happen in the ideal case. This takes me back to what I was mentioning in the theory part, that whenever you use the greater than symbol and the lesser than symbol in the terminals, it will always overwrite all existing content in the file that you mentioned. So even if the command on your left hand side is wrong, what the terminal will do definitely is it will first clear out the contents of the right hand side. So you can see that the echo command was wrongly typed or something, but still you can see that head2.txt, the contents of head2.txt was lost. Okay, so is that this part clear? Okay, seems like no more doubts. The same thing can happen here. So this is one of the very famous commands that we have been using now. So instead of the head part, now I've done it to tail, and now you can see that I have used two greater than symbols. So ideally, what this should do is, as mentioned in the theory, two greater than symbols will always will not override; it will append. So head.txt already had 5 initial files, and now it should have the last 5 files. So there should be 10 entries in head.txt. So yes, indeed you can see that the last 5 cases here, all of these five are the ones that we just now input, and the content was not overwritten; it was appended. On the other hand, if you do just this single, and if you use a single greater than symbol, you can see that the file got overwritten, and we have only 5 entries. So the input part works in the same way, uh, but like there are no commands to take input from a file, so we will skip that part. But as a general note of measure, suppose you're compiling a C file, then in the end you have .a .out, and you use this. So what, like I don't have a compiled file right now, but what this will do is take the contents from input.txt and pass it into the command line variables of the .out function. So if you have been using C++ and if you have been writing command line stuff there, like what should I say, the arguments in the main function, all of those get passed into from there. Okay, so that's it from my side. Are there any more doubts? Any questions? Or did you understand everything? Just let me know in the chat section. Okay, seems like there are no more doubts. So that's it from my side. Akshat, can you take over?
Yeah. So can you hear me?
Yes, you're audible.
Okay. One. Okay. Yeah.
Looks like Akshat is facing a bit of an issue. Like, we'll just wait for 5 minutes.
Yeah. Am I audible?
Yes, Akshat, you are audible.
And my screen is visible.
Yes.
Yeah. Okay. Sorry, everyone. I do not know what happened. Okay. So I'm going to be taking CLI editors now. Okay. So CLI editors are basically any form of some form of editors which are used to edit text files or any source code, but they are right within your terminal. So you don't need to open anything, open any GUI, right? So before actually covering command line editors, there's one editor I'm sure all of you are familiar with. That's gedit. So that's what there in Ubuntu at least. So when you open gedit, uh, this GUI editor opens up.
So I'm sure you all must have used this sometime in the college labs. So there's nothing to explain about this editor. It's just a normal GUI editor, and it works as you might expect, right? Okay. So I'm just going to close this. Okay. So that's a GUI editor. Now, another CLI editor, the first one that I'm going to show you is called Nano. So you must have seen Shubhankar use Nano in the previous session. So Nano is I think it's the easiest CLI editor to understand. So if you see out here, it shows that it's Nano, and so this is the version. Okay, is there any problem with my screen?
No, it is visible. We can't see.
Okay. Okay. So this new buffer here, it means that right now, if you notice, I did not specify any file, right? I just said Nano. So this is just opening a new buffer. It's not actually a file right now. Okay, so this central part here, it's actually the text, the buffer, and you type into this, right? You can type anything into this, and Nano is the closest to a normal GUI editor, so you can just move normally with your arrow keys. You can press enter to go into new lines. You can move around normally like you would expect in normal GUI editor. So okay, so we haven't saved this file yet. So how do you save this file? You might notice this shortcut here, right? Write out, and this stands for the control key. So you can press Control O, and it asks you the file name to write to. So I can just specify a file name, and then when I press enter, so you can see that now instead of showing new buffer, it's showing me the file, and it's also showing me that I have written 4 lines. So that's simple saving a file. Now exiting Nano, you can see that this shortcut is for exiting Nano, or rather it's not a shortcut, it's the only way to exit Nano without the mouse. So you press Control X and you have exited Nano. Now to open a file with Nano, so you specify the file like this. So command and the argument, right? So nano file.txt, it opens the file that we just put. Now there are a lot of shortcuts in Nano. You might see these are some of the shortcuts given here. And so basically for selecting text, you specify something like setting a marker. A marker is where you start selecting from. So if I press Alt A, so it has started. If you notice here, it's written mark set. So now if I move using the arrow keys, this text is getting selected. Okay. So what if I wanted to copy this? The shortcut is Alt and the raise to sign, or Alt 6. Actually, Alt 6. So and then you can just paste it using Control U. Now I know these shortcuts are very different from what you are used to, and I don't expect you all to, and no one expects you all to like learn these right now. But I just wanted to show you that CLI editors can be very, very different from GUI editors. And Nano, and let me tell you, Nano is the closest one to GUI editors. So yeah, there are a lot more weirder editors coming. Okay, so seeing as we are short on time, I won't go very deep into Nano. So if I want to exit, and now this prompts me save modified buffer. So if you notice, we made some changes, but we didn't press Control O. We didn't save the file. So if we write Y, it will save those changes. This is similar to when you like close a in any GUI editor. If you directly close a file, it will ask you to save changes or not. So I'm just going to press no, and it won't save the file. So that was Nano. The second editor that I'm going to take is Vim, or originally VI. So in my system, I have Vim installed, so it actually opens Vim by default. But there isn't much difference as far as the basics are concerned. So Vim is another command line editor. Okay, so basically there is the concept of modes in Vim. Like there is a insert mode, there is a normal mode. So by default, Vim opens up in normal mode. So if I type something, for example, you'll see me typing something, but nothing appears on the screen. So that's normal mode. Normal mode won't allow you to type. To actually insert some text, you go into insert mode, and to go into insert mode, you type I, and now if you notice, this part says insert. So now I'm in insert mode, and now I can type normally. Okay. So why are there two modes? Why can't everything start in insert mode? So normal mode actually allows you to do a lot of things, like basically the cutting, copying, pasting, deleting stuff that can be done in normal mode. So to go back from insert mode to normal mode, you press escape. So if you noticed, the insert part, the insert text went away here. So now I'm in normal mode. So yeah, so there are a lot more. There are too many shortcuts, too many keystrokes in Vim, and you don't have to remember them all. Just remember the important ones, like I just showed you. To go into insert mode, escape to go into normal mode. So one important thing that most people ask is how to exit Vim. Like that's a running joke. So to exit Vim, you have to enter what's called a command. So commands in Vim are specified using colon. So if you enter a colon, that's a shift and semicolon on a keyboard. So colon. So you notice that it appears here instead of here, and you have to be in normal mode to do this. Right? If I'm in insert mode and I enter colon, it will just appear as a colon. You have to go into a normal mode, enter colon, and then it will appear here. So here you can enter commands. So to quit, the command is Q, but now this won't allow me to quit. That's because I have some unsaved changes. So I can either save them, which can be specified by W, like a colon W, and then the file name. So I'll just say vim.txt, and then if I press enter, so now it's saved as vim.txt, and now I can exit normally. Okay. So yeah. Again, I'm repeating this, that it's okay if you can't understand all of these commands, all of these keystrokes at once. It's not actually required to know all of it, but and even so, it's impossible to get comfortable with this in a day, not in a day, in like 10 minutes. But the purpose of this session is to actually introduce you to CLI editor. Right. So just to show you that CLI editors aren't always boring, I will actually show you how customizable they can be. Just a short. So this command is basically, it is just reconfiguring my Vim how it is supposed to be. So you can see that so a Vim can also look really nice. It can also be used as a normal text editor. So I have also added these helpful things like it's showing normal mode. Now I'm in insert mode. So things like that. I've also made a lot more changes. So yeah. Now the last editor that I want to show you is Emacs. So Emacs is also a very popular editor. Now you can open Emacs in the terminal, but I have chosen to open it in GUI mode. So Emacs, people call it's technically a text editor, but it is much more than that. You can do literally anything in here. I am not going to go into the specific how key bindings of Emacs. You can actually use these tutorials, but I'll just like to show you just for some fun what Emacs has. Yeah. So if you can just read this list, it has games. Okay, a text editor which has games. I think even VS Code doesn't have games, okay, by default. So yeah. It has Tetris. Okay. So don't ask me why does Emacs have games. The creators just decided that it would be cool to have them. Yeah. So basically, my point is, again, like I'm sorry to say this again, but this part of the session wasn't meant to make you comfortable with text editors. Rather, it was just to introduce them to you. And also, we are kind of running short on time. But okay, so why do people use CLI text editors? I mean, इतना अच्छा VS Code और वो सब है तो क्यों ये use करना है? So you firstly, it's the same debate as GUI versus CLI. So CLI is inherently faster. Graphics is very resource hungry. It takes up a lot of resources and hence it can be slower. Also, if for example, if you use SSH or something, some remote access protocol, and you are basically using another computer. Now that computer, and so you're basically using the terminal in that computer. So you will have to have some knowledge about CLI text editors to actually do something. And also, it's just cool, right? You might think this is too much like hard work or too much useless work. But once you get comfortable with something like Vim or Emacs, you'll start disliking normal GUI editors because you can be a lot more efficient with something like Vim and Emacs. And to the extent that even VS Code has plugins for Emacs and Vim. So yeah, you can just just explore these editors on your own. And if there are any questions, then please enter them in the chat section. Yeah, I know I didn't explain much, but yeah, if any questions, then I'll be happy to answer them.
Akshat, we have a question.
Oh, yeah.
What is the .bash rc file?
Yeah. Okay. So on Linux systems, bash rc file is like a configuration file for a particular user. So if you see, this is my bash rc file. Okay, I'm pressing J and K kabse because that's the way you move around in Vim. So you can see that like any forms of terminal configurations, like for example, if you notice my theme and all, this is where you set that. If you noticed my prompt, it's not the normal Ubuntu prompt. So even that I changed it in the bash rc file. You can also set aliases. Yeah, so you can see that I've set some aliases out here. Just to like they're just aliases. So if I enter git, it will change that to git status. So that's just basically some things that you use bash rc for. Now I'm not exact. I'm not. I don't have complete knowledge about bash rc, but it's very useful. I mean, and it's very important. Don't mess around with it. So okay, any more questions? So basically, anything that ends in rc is like a configuration file for something. Like you might have seen me changing my Vim RC. So that's a configuration file for Vim. The bash RC is like a configuration file for the bash terminal for a user. Okay. Any questions? Oh yeah. Paths and environment variables. Yeah, totally forgot about that. Okay, so if there aren't any questions, then Shubhankar or Seth, would you like to say something to conclude?
Thank you, Akshat. With this, we would like to conclude today's workshop. I hope that you were introduced to many cool and new things, and that you would like join Team CLI from today onwards, or perhaps after exploring some more things. Um, Important things about after the workshop. So we'll send you the feedback forms on the group. So please fill those up. And regarding the recordings of today's workshop, we'll also share that on the groups. And we have also have a set of resources that you can explore. So we'll send that link as well. So apart from that, if you have any questions or if you have anything to say, please let us know in the chat section. Otherwise, we can conclude today's workshop.